Hello, my name is Dustin and welcome to Networking. Net Plus Basics. The Network Plus exam is an entry-level networking certification from CompTIA. This section will cover some of the basic knowledge required for the Network Plus exam. Networking concepts. The Network Plus exam covers many basic topics of networking, and we're going to discuss a few of them in this section. First, we'll go over what the OSI, or Open Systems Interconnection Model, is and how it compares to the more modern TCPIP model. After that, we're going to go over IP class ranges and how you can distinguish a private IP address from a public IP address. Once we've gone over the basic addressing of an IP network, we're going to go over subnetting and CIDR notation. We'll then discuss network communication and the difference between a unicast message, broadcast message, and multicast message. Lastly, we're going to discuss several common ports and protocols and what they do. Let's get right into it. So first, we're going to go over the OSI model. The OSI model contains 7 layers that characterize and standardize the communication functions of a network without regard to the actual physical hardware that sets up the network. So, in short, that means it can give you a basic visual of everything going on in a network, which can help with design and troubleshooting issues. An easy way to remember the 7 layers in order from the top, or layer 7, is all people seem to need data processing. So from the top, the layers are application, presentation, session, transport, network, data link, and physical. The visual on the right lists all of the layers, what happens in each layer, and what data is referred to at each layer. So let's start at layer 7, the application layer. This is what most users will actually see. It's the application being used, like your web browser. Going down, we've got layer 6, which is the presentation layer. It's the preparation layer for the data. So it prepares the data in an application format for a network format. So this is typically where encryption will take place. Going down, we've got layer 5, which is the session layer. When any two devices need to communicate, there needs to be a session created. This is where that will happen. It will negotiate how long a system should wait for a response and when to terminate that session. Layer 4 is the transport layer. This coordinates the data transfer between the systems. The best known example of the transport layer is the Transmission Control Protocol, TCP, which is built on top of the Internet Protocol, commonly known as TCPIP. TCP and UDP port numbers work at layer 4, while IP addressing works at layer 3, which is the network layer. So again, layer 3 is the network layer. This is where routers function and where routing takes place. As I mentioned before, this is where the IP address comes into play. You'll commonly hear IP address referred to as a layer 3 address. Layer 2 is the data link layer, and this provides the node-to-node data transfer, and it can handle error correction from layer 1. This is where you'll see the MAC addresses, commonly referred to as a layer 2 address. Layer 1 is the physical layer, which is the actual electrical and physical connections of the network. Next, we're going to go over the TCP/IP model. So the TCP/IP model is also an open standard networking model. In the TCP/IP model, though, there are only 4 layers instead of 7. Layer 4 is the application layer, which combines the application, presentation, and session layers from the OSI model into a single layer. Layer 3 is the transport layer, which lines up with the transport layer in the OSI model. Layer 2 is the internet layer, which lines up with the network layer in the OSI model. Lastly, layer 1 is the link layer. This combines layers 2 and 1, data link and physical, from the OSI model. And on the right, we've got a nice graphic here showing how those layers line up.